In this lesson, we are going to look at parabola. We've looked at parabolas before in the form of y equals x squared. And those are functional parabolas, or they're functions, which means they either are like this or they were like that, depending on if there was a value here and now. They could be in different locations and things if there were more things after it. Well, right now we're just going to look at things with the vertex located right at the origin. So we have two different ways that we're going to look at parabolas because they're not always going to be functions. One is an equation like this here where it says x squared equals 4py, and another one where it says y squared equals 4px. In these two different ways, as you notice, one of them is similar to this and the other one is not. This one is the one that is similar. So these two would be similar to what you have when you draw these, and this one would not be. They're all still parabolas. They all will look the same, it's just they're not going to be in the same places, and they may be turned sideways. So these will still look like a function. These are not a function. And so since these look like a function, they're either going to open this way or they're going to open that way. And if these are not a function, well, they're going to open to the left or to the right. And how do we know which is which? Well, that all depends on this right here. That part of it. First thing you should know that in either case, the vertex is at 0, 0. And the value that is the important one is the value of p. Whatever the value of p is the distance to the focus point. And the opposite of p is the distance to the directrix. Now, the focus is a point, and it's inside parabola. The directrix is a line. And the significance of these two things would be the parabola is equidistant from both. So wherever you have, say you have your parabola, the focus point is here, the directrix is there, and no matter where you're at on the parabola, say right here, this distance and that distance are the same. Well, if you're over here, that distance and this distance are also the same. Okay, so my drawing isn't perfect here, but that's the whole idea of where the focus and the directrix are located. No matter where you go on the parabola, it's going to be the same distance. And that distance is whatever the linear term is being multiplied by, and it's 4 times that, 4 times a value to equal that number, will get you there. I don't think I explained that very well, but we'll look at some examples and then hopefully you'll follow what I just tried to say. All right, so here's our first one. It's y squared equals 16x. So we know now that since it is center is going to be at 0, 0. Since it is y squared, that means it's going to be either this type or that type. And in our general equation, it's y squared equals 4px. So 4p has to equal 16, which means if you solve for p, you would divide by 4, and so p equals 4. And so our focus point is going to be 4 to the right. It is going to be at 4, 0. And our directrix is going to be 4 to the left. So at the line x equals -4. And then our parabola is going to be in here somewhere. Like that. Now, to know the exact shape of it, you can put in some values for x and y, but you should also know that because the focus and the directrix are always the same distance, well, since this is 4 from here to there, and that is 4 from there to there, this total distance is 8. So then that means if we go 8 this direct from this point, we should also find another point of our graph. So if there's 1, 2, 3, 4, 5, 6, 7, 8. Right there's got to be a coordinate. And if we go 8 this way, there's got to be a point right there. Because this is 8, so that has to be 8, and that has to be 8, because this has to be 8, and that also has to be 8. And so there's how our parabola should look. So I'm going to get rid of the original one that I just free-handed in there. Now I can draw it better. And it's going to go like so. And now the importance of this focus point is that when things come into this and they bounce off the parabola, they will reflect and go directly towards that focus point. So it's coming here, and it's going to bounce and go there. That's why satellite dishes are the way they are. The satellite dish looks like this. There's your satellite dish. Let's go like that. And then there's some point on it. There's a little bar that holds the thing out there. Well, that helps all the signals get reflected into that little point. Okay, so there's one example. Let's look at our second example here. X squared equals 20y. So this one, because it is x squared, it has to be an up or a down type of parabola. And since it's 20y, this right here means that 4p must equal 20. So we divide by 4, and p is equal to a positive 5. So on our coordinate plane, we know our vertex is at 0, 0. The focus is going to be 5 away from the vertex, so 1, 2, 3, 4, 5 up is our focus. And that coordinate is at 5, 0, 5. And then we know that 5 down, there is our directrix, which is at y equals -5. And since this is 5 and that is 5, this total distance is 10. So if we count 10 this way and 10 that way, we have what our parabola will look like. And if you want to know more points on that, you can substitute values in for x and y or put it in your calculator. And so there you have another example. Here we have one that says the directrix is x equals 7. Write the equation for this. Well, so let's see this. The directrix is x equals 7. That means we have our line going like so. Well, we know that our vertex has to be here, and if this is the directrix on the right, the parabola has to open like so, and the focus, if this is 7, then it has to be -7, 0 is the focus, which means the value of P is right there. And P is going to be a -7. And because it is opening left or right, that means we are dealing with y squared equals 4px. And so we know that p is a -7. Our equation is going to be y squared equals a -28x. All right, so on that worksheet, you can do the left column from 22 to 79 and from 42 to 50.